Hello class, welcome to 6.6 Applications of Systems of Inequalities. The first set of examples we'll look at here are going to be working with one inequality, and we'll gradually kind of work our way up to two inequalities and working with our systems. But if we look at this first one, suppose your class is raising money for the Red Cross. You make $3 on each basket of fruit, $5 on each basket of cheese. Write and graph an inequality to show how many items of each type must be sold to raise more than $100. So this kind of looks like we're going to be looking at missing out on our basket of fruit. So we'll say X is going to be the number of fruit baskets. And then that's going to make our Y equal to a cheese basket, number of cheese. Because we already know the prices, so really what we're looking for is how many items, okay? So if we write an inequality, that means it's going to be 3x plus 5y, and we want to raise more than $100. So that means we want to be greater than or equal to 100. So if we're just looking at one system here, what we're going to look to do is solve and find our graph. So before we get started, we know that x-axis, we called that our number of fruit. And over here on the y, we said that that was the number of cheese. And now it's going to be a matter of getting a graph. So easiest way to graph, standard form, finding our x-intercept, so that's when y equals 0. So the first thing we're looking at is 3x is equal to 100, so we're going to divide by 3. Now this one's not going to work out super nice, so we're going to be looking at, what is that, 33.3 repeating. And if we look at the y-intercept, that's when x equals 0. So if x equals 0, that gives us 5y equal to 100, divide by 5, and y equals 20. So that's going to tell us if we're going to buy our number of cheese baskets on the y-axis, we need 20 baskets. If we're looking at x baskets, we're going to want 33.3, so 31, 32, 33. So that's going to be somewhere like over here. And graph our line. So once we have our line graphed, we are looking at, do we need less than or more? Because this is an inequality. So if we plug in 0, 0, well, that's definitely not less than 100. So that means we need to shade and get above this line. So what that's really going to be telling us here is anything on the line or above the line, because remember, this was also equal to, any of those combination of fruit and cheese baskets going to get us over that $100. So we can kind of look at this and say, well, if I only sell $25 fruit baskets, I better be looking up to here, and I better be getting at least 5 cheese baskets or more. If I only get 10 fruit baskets, I better be going all the way up here, and that looks like I'm going to need at least 14 or more. Same thing, we could look here from 15. If I sell 15 cheese baskets and look over, well, that looks like, what is that, about 7? Well, it looks like 8 is going to be above that line. Oh, that might be a 9. Might have to be a little bit closer. So if we only get 8, we're going to need at least 9 there. So let's answer a few questions about this. So this first question is going to ask, if your class sold 20 fruit baskets and 15 cheese baskets, did you meet your goal of making over $100? Well, if we go over here to 20 and go up to 15, that's going to take us somewhere up in this region. Well, that is in our solution area, so yes, it is in the shaded And if it's in the shaded, that is going to be our solutions. And if we don't trust that and we want to try to verify that, we could verify that with some math. So what that's going to have us do is say, well, if we took our $3, if we took our $3 times, well, that was our fruit baskets, plus $5, and it says we're trying to sell 15 baskets, is that going to be more than 100? So what's that going to be? 60 plus 75. Well, yeah, $135 is definitely more than 100. Okay, so again, going to practice one of those on the next page, so take a minute and do that. So pause here, take a minute to kind of solve and work through before you move on. Today we're going to be looking at some inequality word problems. Some are just some basic inequalities. Some will end up being systems of inequalities. But let's take a look at this first example. You can work at most 20 hours next week. You need to earn at least $90 to cover your weekly expenses. Your dog walking job pays $7.50 per hour, and your job as a car wash attendant pays $6 per hour. Write a system of linear inequalities to model the situation. So if we look at this, two of the things we're looking at here, if we are looking at our, let me see here, where's my pen? If we are looking at most 20 hours next week, we are going to be looking at two different things, right? We're working at the job as a car wash attendant and the job dog walking. So if we look at X, we can call that dog walking. And if we look at the other one, Y, we can look at car wash. Okay, now both of these here are talking about the hours worked. Okay, so we got to keep that in mind. So the first one, if we're looking at an inequality, could be, well, if I'm working my X hours plus Y hours, I need to be at most 20. So I better be staying less than 20 hours because we don't want to go more than that. We also need to earn at least $90. So when we do our dog walking job, well, dog walking was $7.50 times our hours. Our car wash was $6 per hour's car washing. And if we want to make at least $90, we are looking at greater than 90. Okay, so what we're going to want to look at next is getting this into our graph. So the first thing we want to look at here is if we're looking at our x-axis, we know that this was defined as our number of hours dog walking. And we can look at the y-axis as the number of hours car washing, or at the car wash. So when we look at this system, we're going to have to graph two different ones. So we can start with this first one. We'll do all this work, continue to do this one in red. And if we're going to graph x plus y is less than 20, our easiest thing to look at here is going to be our x and y intercepts. So we're going to break it in two because we're actually going to have to graph two of them. But if we look at our x-intercept, remember that is when our y equals 0. So if we plug that in, we are looking at x equals 20. That's going to tell us that we can go up here and say, well, that's what we're going to be looking at for 20. And what we also want to end up looking at is our y-intercept. So that would be when x equals 0, which would also be y equals 20. So if we are looking at our number of hours working, let's make sure we take a second to connect those dots. The second thing we need to look at is this second equation. We'll do this one in blue. So if we're looking at 750x plus 6y, okay, we need to figure out how are we going to get, how many hours do we need to look to get above $90? Well, if we look at our y-intercept of that one, that is going to be 750x equals 90. So if we divide by 750, we'll end up with x equals 12. So we can come down here and say 12 hours walking our dog. And then what we're going to be looking at here is 750 here. So we got to find our x equals 0. So that's going to be 6y is equal to 90. So if we divide by 6, that means our y is going to equal 15. Now keep in mind, these are inequalities. So after we have these lines graphed, remember our red line talking about our hours, that is going to be saying, all right, if I work less than 20 hours, I'm saying 0, 0. 0 plus 0 is less than 20. And then when I look at saying I need to make more than $90, well, that blue line is kind of representing your more than $90 line. So if we plug 0, 0, well, that's not going to get us more than 90. So what we are really looking at here is we need to try to end ourselves somewhere in this middle round. So let's just kind of erase at this point, kind of get rid of those other lines. And what that will allow us to do is kind of focus on that region between those two lines. Those are going to be our acceptable lines that basically get us above our $90 line, but still stay less than all of our combinations that would keep us under 20 hours. So when we look at this, we're going to take a look at some different questions. If we're looking here at like 15 hours, we could go 15 hours of walking, and it looks like we could go up to maybe 5 hours of car washing. That keeps us a total of 20. If we look over here at like 10, well, if we go to 10, we better start at least here, which I don't know what that's at, a little bit over like 2.5, something like that. But we better be working at least 3 hours. And we better be staying under 10 hours. So we're kind of just interpreting this graph. If we know we're going to look at 10 hours of car washing, well, that means we're going to need at least 4 hours of walking our dog. So anywhere in between there, those combinations are going to help us answer these questions. Okay, so the first question here is talking about if we work 5 hours at the car wash, how many hours would you need to walk dogs to make your goal? So if we look here at 5 hours of car washing, that means if we're going to make our goal, we're coming over here, it looks like, to at least 6, 7, 8 hours. So we need to make at least 8 to get us to that $90 mark. But we would also need to kind of look at this and say we can't go past 15. So we need to go somewhere between 8 and 15 hours. Is that possible to do given this situation? Well, absolutely. We can definitely look at 5 plus 8 is 13. 5 plus 15 is 20. And like I said, anywhere in here, any of those hours in between are all going to end up getting our total above that 90. List 3 other combination of hours at each job. So other combinations are going to end up anywhere in this graph. So if we look here, that could be 15 hours dog walking, which would be 3 hours of car wash. If we jump up here a little bit higher, we could say, 5, 11. We can even jump up here a little bit higher and just say maybe I don't want to work any hours walking a dog, but I could work at 16, 17, 18 hours at our car wash. And really, we could have a lot of answers in there as long as they end up in that shaded region. Okay, so take a minute here to pause and work through these next couple problems before you move on and check your work. Okay, so hopefully you learned something here today. Make sure you have these done and ready to go so we can check these in class. All right, have a nice day.